Hello everyone, I'm Brad, and today we'll be doing 12207 target 3. So this problem is one of the earlier parts of the target, right? It's the third question on the target, but it's strictly hard. So let's take a look at the problem. So say a positive integer is p fitting if it contains all the distinct digits of p in a space 10 representation. For example, 81 is 1 fitting and 32 is square 3 fitting, blah, blah. Compute the number of positive integers less than 100 that are p fitting for some prime number p. So we're looking for numbers that contain all of the prime numbers digits. But another way to think of this is we're looking for numbers where we can create a prime number using only the numbers digits. Take a look at the examples, right? 81 is 11 fitting because you can create 11 using only the digits 8 and 1, and 32 is 23 fitting because you can create the prime number 23 using only the digits 2 and 3. If you're looking to create prime numbers, right, it's easier to create shorter prime numbers, right? So let's take a look at prime numbers with just one digit, right? So if we look at the one digit primes, 2, 3, 5, or 7, right? Well, any number that has a 2, 3, 5, or 7 as a digit is going to be that prime fitting because you can create, let's just take a look at the example, right? 32 will be 2 fitting. It has a 2, right? Because you can create 2 using the digits 3 and 2. You don't even need the 3. So yeah, it's easier to create single digit numbers. Another thing to look at, right, is 11. Just for the example, 81 is 11 fitting just because it has a 1, right? You can create an 11 since you're able to use like 1 as many times as 1 if the number has a 1 in it. So basically now what we have, right, is if a number has 1, 2, 3, 5, or 7 as one of its digits, is p fitting. So let's take a chance. I'm going to draw a box, right? And this box will represent all the numbers from 1 through 99. Right? And let's basically write down what we've learned, right? If this section of numbers represent the numbers that contain a 1, 2, 3, 5, or 7, right? We know that all of these are p fitting. So what other numbers are there? Well, the only other numbers are numbers that only contain the other digits, right? 0, 2, 4, not 2, oops, 0, 4, 6, 8, and 9. So out of these numbers, right, a number has to either contain 1, 2, 3, 5, or 7, or it has to not contain 1, 2, 3, 4, or 7, which means it only contains 0, 4, 6, 8, and 9. And so now at this point, we're going to introduce a concept called complementary counting. Complementary counting is basically counting the other of what you want, right? So if we're counting, right, if it contains 1, 2, 3, 5, 7, complementary counting is counting the numbers that don't contain that. So why am I bringing this up, right? It's because now we're trying to count not p-fitting numbers, right? And if we just take a look at this, right, pick a random 2-digit number in here. I don't know, let's say 86, right? 86, right? Is 86 p-fitting? 86 is only p-fitting if you can create a prime number using 6s and 8s. But if you're creating a number using 6s and 8s, what's going to happen is you're going to end up with an even number that's not 2. So it's not going to be prime, which means it can't be p-fitting since you're not able to create a prime with it. And so now we notice here, right, that if you basically create any number using these 4 digits, any number that contains only 0, 4, 6, and 8, it's not going to be p-fitting since you can't create a prime number from those digits. So let's section this off again, write down what we figured out. Numbers that only contain 0, 4, 6, 8. These are not p-fitting numbers. So what remains? The only thing that remain are numbers that contain a 9 and only contain this. So now I don't think there's much else to do, right? We've already narrowed it down so much that at this point we can probably just go through the remaining numbers one by one. Right? So what are the remaining numbers? You have 9, right? You have 99. These are both not p-fitting because, I mean, you can't create a prime number using only 9. It's going to be divisible by 9. Same thing with 90, right? Any number you create with 9s and 0s is going to be divisible by 9. 96 and 69, these are also not p-fitting since 9 and 6 are both divisible by 3, which means any number you create with these 2 digits is also going to be divisible by 3. What else remains? 89 and 98. Well, I mean, 89 is a prime number, so this is obviously p-fitting. And what else is there? The last ones are 49 and 94, I believe. And well, I mean, this is kind of tricky, right? I don't think there's it's not really clear as to why this should be p-fitting or we should not be p-fitting, but there's no obvious argument to why it's not p-fitting, right? If you're trying to create a number using 4s and 9s. And so it feels like intuitively, if you use enough 4s and 9s, you'd be able to get a p-fitting number. So as a guess, you should think that it should be p-fitting. And I mean, if you just go even a little bit further beyond the 2-digit numbers, right, you'll find that 49 and 94 are both 449 fitting and 499 fitting, which are both prime numbers. So now what we found out. In this section, what we have 4 numbers here, right? Just these 4 numbers are p-fitting. In this section, we have 0 since they're all not p-fitting. In this section, the numbers that contain 1, 2, 3, 5, or 7, there are 75 of these. So in total, right, how many p-fitting numbers do we have? We have 75 plus 4 for a total of 79 p-fitting numbers. So let's take a chance to recap what we did in this problem. It's far from easy, but we took a chance to do what I call organized casework, right? We just kept splitting our total numbers, right, 1 through 99, up into cases, and which sectioned off our numbers, right? And so by doing that, we make as big chunks as possible, and we kept it organized, right? We kept track of exactly what we were doing. These are the numbers that were in our first case, and these are the remaining numbers that we have, right? And again, what we did, right, in our second one, we were like, okay, this is our second case of what we did, and then these are the remaining numbers. And so organized casework is basically just all about making as big of cases as you can while keeping track of everything. That's the most important things. And if you can do this, you'll be able to solve all sorts of counting problems.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.